So program evaluation and review technique. Okay. So this is a different method when you take when you compare with a method like critical path method. So how it is different from critical path method is that instead of a single duration, like I explained, it assumes 3 different durations for one activity, for a single activity, and then after assuming, it uses statistical signs to verify how much of variation is, or how much of uh, deviation to the reality will be there or not. Okay, so it uses the signs of probability and statistics to verify your assumed duration. Okay, or also it gives you that whether how much of probability based on the assumed duration, based on the assumed duration for activities, the total project, when you calculate total project time, you calculate how much of probability is there for it to complete in the given assumed time. Whether high probability is there, 90%, 95% probability is there, or very less probability is there, 20%, 30% probability is there. Okay, so that way it verifies that the assumption that you made is more or less correct or not. Okay, so that method is what is PERT, which is essentially used for unknown situations, uncertain situations, when the project is being executed for the very first time, when you don't have any previous record of the activities or the durations, when it is very, very newly done, surrounded by a lot of uncertainty. And such cases, this is one of the most suitable methods or very efficient methods for scheduling. So again, the difference between CPM and PERT is that PERT uses probability. Okay, it assumes a probability. Whereas critical path is, it is called as deterministic, which is already a duration is determined, and based on that the calculations are made. That is deterministic. When it is made on a probability value, when it is made on a 3 or more than one estimate, and the correlation between the estimates are made using probability, that is called as probabilistic approach. So that is the difference between CPM, critical path method, and program evaluation and review technique, PERT. So as it is shown in the slide, it is a statistical and probability approach for scheduling. Answering all this, we will almost cover all the possible applications of PERT. We will answer. Is it clear till this point, friends? Is it clear?
Yes, sir.
Okay. Now, next step, we know the activity predecessor, optimistic, most likely, and pessimistic. So we are going to calculate the value of TE, or expected time. So TE of expected time. Let us just say for one activity, okay, one activity, okay, it is TO plus 4TM plus TP by 6. TO plus TM, 4TM plus TP by 6. Okay. Let us take for first activity A. For first activity A. What is the value of TO? 16. So 10 plus 4 into 16 plus TP. TP value is 20. So 10 plus 4 into 16 plus 20 divided by 6. So that is what I have shown. For TE, expected time of A is 10 plus 4 into 16 plus 20 divided by 6. The value is 15.7. 15.7. This value is 15.7. Friends, are you able to follow? Okay. So similarly, we calculate the values for all other activities. TE values for all other activities. If you take for B, then it is 7. Okay. 7 plus 4 into 10 plus 4 into 10 plus 20 divided by 6. Can you just somebody quickly calculate in your calculator and tell what is the T value for B? 7 plus 4 into 10 plus 20 divided by 6. Is it 11.2? Is it correct or wrong? Can somebody tell?
Sir, correct, sir, correct.
Okay. So same way you need to calculate for all other activities. Similar method only. Okay. Right. Now we have calculated the expected time. Okay. Right. For all activities. Now this expected time will be the duration based on which we will calculate the critical path. So for each activity, we'll calculate the single TE value and then we'll calculate the forward and backward path. That I will come to it. Okay, right. Now, same method, we need to calculate the standard deviation and variance. First, we'll calculate the standard deviation. What is the formula? Standard deviation formula is TP minus TO divided by 6. TP minus TO by 6. Okay. For example, for activity A, it is TP is 20. TO is 10. 20 minus 10 by 6. 20 minus 10 by 6 is 10 by 6. So how much is 10 by 6? 1.67. 1.67. For B, it is 20 minus 7 by 6. 20 minus 7 is 13. 13 by 6 is 2.17. Same method we need to calculate for all activities. Is it clear, friends? Is it clear? This is sigma square. You can just simply find the square of the standard deviation value. 1.67 square. Standard deviation is sigma. Variance is sigma square. 1.67 square is 2.78. 2.17 square is 4.69. And same way we need to calculate. Okay. So I've just shown the sample calculation also. Okay. 1.67 square, 2.78. Right. Now, next step is network calculation. So how are we going to calculate the network? Based on the expected value TE values. Because now we converted the 3 different estimates into single duration for every activity. Now it has almost become like a normal critical path network calculation only. So for every activity, we are calculating the forward and backward pass. Okay. A, we take this 15.7. Okay. And B, 11.2 and so on for all activities. Already we calculated the network. So now we calculate the forward and backward pass. This also very familiar for you. So for example, A is 15.7, 0 and 15.7. B predecessor is A. So it is 15.7 plus 11.2, it is 26.9. For D, it is predecessor is B. So 26.9 is the early finish. So 26.9 plus 1844.9. For E, it is B is the predecessor. So 26.9 plus 29.5, 56.4. So likewise, we need to calculate activity 81.2 and 89. So forward and backward pass, the same method only we calculate. So the duration of the project is 89 days. 89 days. And the critical path here, which activity is having the same early start and late finish and early finish and late finish. A, B, E, G and H. So that is the critical path. A, B, E, G and H is the critical path. Any doubts in this? Any doubts, friends?
No, sir. No, sir. It is clear, sir.
Any doubts, friends? Okay. Right. Now we are going to bring the central limit theorem. Okay. Now I just go back to the central limit theorem. It says that mean of the sum. So sum here means critical path. So now onwards, we are going to calculate only the critical path and consider the individual activities in the critical path. So that is what we are going to do next. Okay. So what is the critical path here? It is A, B, E, G, H. Okay. So we are going to filter out A, B, E, G, H and corresponding all the values, expected duration, standard deviation and variance of these critical activities alone. Okay. Now these critical activities alone, the expected time is what? For each activity A is 15.7, 11.2. For E 29.5, 24.8 and H is 7.8. If you add all of them together, this is 89. Okay. Now this 89, okay, is the duration of the project. Okay. So the duration of the project is also called as mean duration of the project. Mean duration of the project. What is this? Mean duration. So mean duration of the project or critical path or sum, this is what we call it as the mean of project. This project is what we call as sum. So based on central limit theorem assumption, this is what we mean by sum, isn't it? As per the critical limit theorem.
Like this is
Central
sum of
limit
mean,
theorem.
no, sir. Sum of mean as per
Sum of the mean.
critical.
Sum of the means is what? Sum of the means is this mean statistical mean we have already calculated now. Yes or no? 15.7 plus 11.2 plus 29.5 plus 24.8 plus 7.8. That is what is 89. Correct? That is the mean of the
Yes, sir.
project. So that is what is mean of the sum is sum of the means of individual activities. Now you are able to understand?
Yes, sir.
Right? Now, same way we apply for variance. Because for the overall project, we need the mean duration and mean variance. So now for the variance, that also we take from the previous table. We have already calculated now here. Variance we have calculated for all activities. Now we consider only the critical activities, which is AC, AB, EG, H. Okay. So for that, we take the variance values. 2.78, 4.69, 1.36, 1.36, 0.25. Now, for the projects variance we are calculating by adding the some individual variance of or sum of the individual variances of activities. This you add, you get 10.44. This you get variance of the project or variance of sum. That is the second statement in the central limit theorem. Variance of project. Variance of project. This again is the term, we call it as sum. So the variance of the sum is sum of the individual variances. Sum of the individual variances is the variance of the sum or variance of the project. Now this is also true, or this is also we calculate as per the central limit theorem. Now is the most important point where we need to be more careful. Now the central limit theorem, in the beginning itself I told it is applicable only for what? Mean and variance. It is not applicable for standard deviation. Do you remember? Did I tell or not?
Yes, sir. Yes, sir. You told, sir.
Okay. So even though we have the standard deviation of individual activities, we should not add the values to get the standard deviation of the project. We should not add that to get the standard deviation of the project, because that sum of the standard deviation is not there in the statement. It is only mean and variance are there. So how to calculate the standard deviation of the project? We know that standard deviation is sigma and variance is sigma square. Okay. Now, my question is, we know sigma square. How can we calculate sigma from sigma square? We know sigma square, variance of the project we know. How can we calculate
This
sigma? Can we
square
take
root of
square root?
variance, sir.
Yes, exactly. So if you take the square root of variance, we will get the square root value. Now what we have to do? We need to take the square root of the variance value we have calculated. Square root of the variance value we have calculated. That is what is 3.2. That is what is 3.2. Friends, are you able to follow?
Yes, sir.
Okay. But wrongly, if you add all these things, this value will not be 3.2 because of the central limit theorem. That mistake we should not make. Okay. So till this point, everybody is clear. So we know the projects three important parameters. We know mu value or mean is 89. That is the mean duration of the project is 89. Sigma is equal to 3.2. 3.2. Okay, right. Now, how are we going to calculate the probabilities, okay, of the values? Very importantly, there is one formula which is called as Z value. Z value is equal to X minus mu by sigma. X minus mu by sigma. This is a very important formula. X minus mu by sigma. Now, X is the variable for which we are going to find the corresponding probability. This X can be anything. For example, for a duration, what is the probability? 80 days duration, what is the probability? 90 days duration, what is the probability? So that for what value you are going to find the probability, that value will be the X. Okay. So we will calculate the Z value. Then based on the Z value, we will refer the standard normal distribution table, the Z table that I have just shared with you in WhatsApp. In that, we will find the Z value, and for the corresponding Z value, what is the probability, that we will refer the table and find out. So that is the procedure. Okay. Is it clear for everyone so far, friends?
Yes, sir.
Okay, right. Now, so what is the critical path? First question, critical path is A, B, G, D, A, B, E, G, H. Critical duration is 89. So first two questions we have answered. Now we are going to calculate the third question. The third question is, here is what the actual PERT application starts. Probability of project duration greater than or equal to 95 days. Now, to understand the concept of how to find the probability, first we need to understand what is the probability curve for this particular case. So what is the probability curve for this case is, for example, if you take a probability curve, okay, so this is the, for our current problem, this is the curve. Okay, now you have the mean. So here, okay, just adjust, the curve is little bit going across. Now, what is the central value? What is this central point?
Sir, 89, sir.
89, exactly. Okay, 89. Now, every value will be located at a standard deviation of sigma. So what is the sigma value? 3.2. 3.2. So what is the next value? Next value will be 89 plus 3.2, which is 92.2. Yes or no?
Yes, sir.
What is the next value? 95.4. Correct or wrong? This will be 95.4. Yes or no, friends? This is 92.2 and this is 95.4. So 1 sigma is 92.2. 2 sigma is 95.4. 3 sigma is 98.6.
Correct, sir.
Correct, na?
Yeah. Correct, sir.
Right. Okay. Similarly, this is minus side. Okay, this is minus side. So what will be this point? 89 minus 3.2. First value. 89 minus 3.2. 85.8. Yes. 85.8. And this will be
82.6.
82.6. Okay. Be
79.2.
79.2.
79.4. 4, sir.
79. So, okay. 79.4. Now we know where the duration values are distributed, isn't it? Now 95 is here. Now what is asked in the question? Probability of project duration greater than or equal to 95. Okay. Now my boundary is here. 95.4 is 95 is here. Okay. Now
The 2 sigma almost, sir.
That is just 95 is almost here. I'll just come back. What is greater means after this to the right side of this curve. Correct or not? 95 and more is the question. So beyond this 95, what my project duration, how much it is, this is what I need to find. Correct or wrong, friends? This is what
So this
I need
is
to find.
question.
Correct? Yes or
Yes,
no?
sir. Yes, sir.
Right. Now I have a question for you. Okay. This is a probability curve. Okay. What is the maximum value of probability you can have for any case, any situation? What is the maximum
Sir,
probability you can have?
100%, sir.
If you convert it to decimal, what it is? 1. Yes or no? Yes or no, friends?
Yeah, I did
100
not
means
get, sir.
100% means 1. In decimal, it is 1. Yes or no?
Okay, sir. Right, sir. Point. Yes, sir. One. Right, sir.
Now, this value of normal distribution curve, the value, this is the whole probability. The value of this whole probability or this value of this entire curve is 1. Do you agree? Because whichever value you take, can it exceed 1? No, right? The value of the whole curve is should be within 100 or 100. Maximum it can be 100. Or the value of the entire probability curve is 1. Yes or no?
Yes, sir.
Yes. Correct? No? Right. Now, let it be. I want the probability of project duration greater than 95. Shall I say that? Shall I rewrite this as? Now, this curve is this is another area. This curve is probability of the project to the left side of 95 or probability of project duration. This particular portion is project duration less than or equal to 95. Do you agree? This particular portion,
Agree, sir.
particular portion is project duration less than 95. Do you agree?
Agree, sir.
Yes. Now, to find the probability of project duration greater than 95, shall I say that from the whole curve, if I subtract the probability of project duration less than 95, I will get this value. Do you agree? From the whole curve, if I subtract this, I will get this. Yes or no? Correct or wrong?
Yes, sir. Yes, sir.
Okay. So that is how we are going to find. Okay. So the whole curve of probability of project duration greater than or equal to 95 is equal to 1. This 1 is what? The probability of the overall curve. 1 minus probability of project duration are equal to 95. Is not equal to 95. Okay. Now this is what I am going to find out. Okay. So for that, I need the Z value. How am I going to find the Z value? We will see. Now we know mu is 89, sigma square and sigma values we already calculated. Based on the formula, this is what I just explained. This is the shaded area. Now, Z is equal to X minus mu by sigma. This equation I already told. This X is 95. This X value is 95. This is what I'm going to find out. Okay. 95. Okay. So how I'm going to find the Z value? Z value, X variable is 95. Z is 95 minus what is the value of mu? 89. 95 minus 89 divided by 3.2. 95 minus 89 divided by 3.2. So it is 96 by 3.2. This is 1.88. I will just this is 1.88. Okay. This value is 1.88. Since I have drawn the curve, it is not clearly visible. But in the PPT, when I give, it's 1.88. Okay. So this is equal to 1.88. So next step is to Z value. For this Z value, I need to find the probability. Okay. Z value, I need to find the probability. Okay. So what I'm going to do with that is, I'm going to refer this table. Okay. Now, what is the value of Z? 1.88,
sir.
So we need to find plus or minus, plus only.
Minus,
okay,
sir, minus. Minus, sir.
Minus, correct. Because it is minus or plus, sir? Plus only.
Minus, sir. Minus, sir.
How minus? How minus?
X, okay, sir, plus, it is plus, sir. X is equal to
Plus
95.
Only.
Yes, sir, plus.
Okay, 95 minus 89. Okay, plus only. Huh?
Okay, sir, plus is there, yes.
Right. Now, we need to find it. So, here in the second page, in that 2 pages are there. First page is for entirely minus values. Second page is for plus values. Okay. Now, in the plus, where is that? 1.8. Okay, 1.88. So, the first column is first decimal place. This column is second decimal, 0.00, 0.01, which means that this is 0.80, this is 0.81, this is 0.82, 0.83, 84, and so on. Now, what we need? 0.88. Where it is? So, we need to find out 0.08. 0.08. Okay. So, 1.8 is here, 0.08 is here, that is 1.88. So, in this row corresponding to this, what is the value we need to find? So, what is that? 0.9699. 0.9699. So, this is the probability value corresponding to 1.88 Z value. 0.9699. Friends, are you able to follow?
Yes, sir.
Are you able to follow?
Yes, sir.
Okay. Now I go back to the table. It is 0.9699. But what is that value? It is the value of probability of project duration less than 95. But what I need? Probability of project duration greater than 95. So what should I do? I should subtract this value from 1. That is the overall probability of the curve. That is what we just discussed a few time back. Okay. So this 0.9699 is only this shaded portion, this portion. Okay. This particular portion's value is what is 0.969. But what I need is here to find this from the whole curve value of 1. I am subtracting this 0.9699. So that is the next step. So this is 1 minus 0.9699, which is 0.0301. So what is the probability of project duration exceeding 95 days? 0.0301 or simply 3%. Simply 3%. Are you able to understand? Friends, are you able to understand?
Yes, sir.
Right.